This is the first of 3 lectures that talk about the deployment pipeline. So the first one will give an overview and some specifics about environments. So overview. So the deployment pipeline is a sequence of actions that move the code you write into production. We'll present it as 4 stages: development, integration, also called build, staging, and production. Some organizations vary these stages. Some have no staging. They do all the testing in the integration environment. Others have multiple staging. They may use one stage for user testing and another stage for other types of quality testing. So each stage has a separate environment, and these environments are separate from other environments. So the notion of environments is key to talking about the deployment pipeline, and we'll go into that in a minute. So if you look at the deployment pipeline, you have collection of developers. They develop their code in the development environment. They check it into a version control system that triggers integration and build, which builds an executable, runs some tests. Again, we'll get into detail. That moves it to the staging. If it passes the test, then it moves to the staging environment, where it undergoes more tests, quality tests. If it passes those, it goes to ready for production, depending on whether you're doing continuous deployment or continuous delivery. And then it goes into production, maybe in the form of multiple instances. And so one purpose of each environment is to perform tests. It has some functional purposes as well, but the types of tests that it uses are either runtime tests or static analysis tests. So runtime tests says you have some portion of the system. That portion grows as it moves through the deployment pipeline, and there's a set of tests that are run on it. And this requires a test harness, and I'll talk about that more in a minute. Static analysis is applied to the source code, and it uses techniques similar to those used in compilers. So it looks for problematic code construction, doesn't necessarily look for errors. It's just things that might eventually turn into vulnerabilities. It also looks for can look for certain stylistic types of things. The types of problems flagged by a static analyzer are those that can be found in the common weakness enumeration, and we'll talk more about that later. And basically, for our purposes here, that's a list of software weaknesses. And a weakness is something that might be exploited to turn into a vulnerability, but it isn't explicitly a vulnerability. So to just give you an overview of the different environments. So in the development environment, you develop your code, and then you run unit tests on each module. So you work on a module at a time, you run unit tests, and then you check it into the version control system, and this will trigger the action of the integration stage. Uh, the integration stage or the build stage uh, compiles your new or change code. It also compiles the code of other portions of your system, of your service, because they have to be linked together, and it wants to make sure to get the latest version. If you're working in an interpreted language, then there's no compilation step, but it still has to retrieve the latest version of all the things that are part of your service. It constructs an executable image. Okay, and again, that depends on whether it's a compiled language or an interpreted language, uh, and then this executable image is then tested for functional correctness. And after the executable passes the tests, it is promoted to the staging environment, which is then triggered. And the staging environment is designed to test quality. What do we mean by quality? Performance under load, security. How about what kind of vulnerabilities might be in your code? Does your code comply with regulations and licenses? Those are the kinds of things that are tested in the staging environment. And again, when we get into this, we'll talk about more detail. Possibly user acceptance test may occur. Depends on the business context of your service. Once a service passes its quality test, it's placed in production. So again, if you're doing continuous deployment, it goes right into production. If you're doing continuous delivery, it gets marked as ready for deployment. And then when it's in production, it's monitored until you gain confidence in it. So the, the developers, the first responders, some organizational entity looks at this particular service with a careful eye until they gain confidence, and then it's part of your regular production environment. So what kind of pipeline has qualities? Every complicated piece of software has a collection of qualities that you use to evaluate it. In pipeline, it's a collection of tools. And so the four qualities we'll talk about are cycle time, traceability, repeatability, and security. So what's meant by cycle time? How long does it take from the time that you committed your code until there is that code, that service that code is in, is ready for deployment? It may be in production or it may be on the staging server, but uh, how long does cycle time take? And if you're doing continuous deployment, that depends on automated testing. If you have human testers, then it's going to slow down the process. Humans are just not as fast as computers. There are other trade-offs in terms of human versus manual versus automatic testing. But if continuous deployment is your goal, then automated testing is essential. Traceability. If something goes wrong with the service in production, you want to be able to track what that was. How did that service come to be? What code modules were included? What tests were run? What tools were used to place it into production? What are the configuration parameters that were used at each step? So there's a notion of being able to trace what happens in the deployment pipeline. And we'll talk about these things in more detail when we get to the particular environments. There's also repeatability. You would like be able to repeat the test. You would like to know that if the test fails at one point, if you run it again and don't change anything, that it won't succeed. Uh, and so this sounds trivial, right? Computers are deterministic, but it turns out that computers are not deterministic anymore because of parallel concurrency. And secondly, uh, your things are happening in the background. So maybe somebody introduced a new version of a library, totally distinct from your development team. And that new version of the library gets included. And all of a sudden, a bug that you're tracking disappears. Or all of a sudden, there's a new bug, one way or the other. Uh, it may be that your test changes the database so that the service that you're testing is going to change the database. And that changes the initial state for the next test. And so you have to restore the database. That's another reason why things might not be repeatable. There's also something called flaky tests. And flaky tests are not repeatable, not because of the two reasons I mentioned, but because of concurrency. So you have parallelism in the system. There are things going on in the background of your system, garbage collection if you're doing Java, getting messages, mail messages, if it happens in the background until you're ready to look at them. SMS messages, the same thing. Maybe your system is doing some sort of backup of something into the cloud. Maybe something's being updated. There are all these things that are happening in the background. And if your particular service is using parallelism and has multiple threads doing multiple things, then it's possible that the error that you get is dependent on the sequence of events, and that sequence of events may be altered if because of these background activities. And so this is called a flaky test when you run it once and it works, and then you run it again and it doesn't work, and you haven't changed anything, and then you run it again and it doesn't work again, but in a different way. Uh, so, yes. And how do you find flaky tests? Well, there's a tool called Deflaker, which is kind of fun, a fun name. But in general, you can look at your logs and see be able to retrieve the sequence of events. Remember, we talked about logs and being able to sequence the types of activities that go on even in parallel. There are a number of security problems that occur. One might be that the pipeline itself is subject to malware injection. So maybe somebody on your team is an attacker. Something like 15 to 20% of data breaches are caused by insiders, and they might have set up your build server to always put malware in so that it had a backdoor so that you could get into any of the software being built by your system. That's a possibility. Uh, and so security becomes an issue uh, during and we'll talk about this, during the staging server, there are security tests you can do on the code, but we're talking now about the security of the pipeline. And the way to enhance the security of the pipeline is to restrict access to the tools. Not access to using the tools, but access to modifying the tools. And so you have a smaller group of people that are going to modify the tools in your pipeline. You may require two people to sign off on every change. Uh, you may notify all the team members that that some piece of software was changed. These are techniques you can use to enhance the security of the pipeline. So again, offline discussion questions. What are the trade-offs between doing quality testing in the integration step and doing it in staging step? Why would an organization choose to do one or the other? What is the relationship between cycle time and the number of deployments per day? Remember, we talked about metrics, and one of the metrics was the number of deployments per day. And what's the relationship between cycle time and that? So now let's dig into environments a little more. So the purpose of an environment, again, except for production, it's to provide a place to perform testing that is isolated from other development or testing activities that might be ongoing. You also do functional things during. You might build the system. You might uh, do some static analysis, a form of testing. Uh, so you might build the system. You might move it on to the next step. But in general, you want to make sure that the tests, the development, the activities that you do inside the environment and the tests that you run are isolated from all the other environments and all the other things that are going on. So what are the requirements? First, you want to isolate. That means the address space of the system that you're developing, the inputs of the particular tests that you're running, uh, the modifications to the database that you're making. One of the causes of system failure is people in the testing phase changing the production database inadvertently. Well, in one case, it wasn't. I did a survey where I asked people what caused system outages from a deployment point of view. And in one case, there was someone who was utilizing the production database, but that was conscious. It wasn't inadvertent. There was a particular reason for it. Uh, Other dependencies might be isolated. You need to isolate the dependencies in the particular environment from the dependencies in the other environment. And so what does it consist of? And we'll go into this, but it consists of a collection of virtual machines or containers. It consists of infrastructure. So the earlier you can introduce a load balancer, for example, into your test, the earlier you can find problems with how your service or your module interacts with the load balancer. You might want to use a logging service as a supplement. Well, the earlier that you introduce that, the faster you can find any problems with how you're doing it. Uh, you have configuration parameters, you have external services, and we'll dig into each of these. So what are the virtual machines or containers? These are the modules, services, or the system being executed in this environment. So that grows as you move through the environments. In the development environment, it's a module. In the build environment, it's a service. In the staging environment, it's either a service or the whole system. Uh, and that grows as it moves through the pipeline. So that's what I just said. You have infrastructure services. So your service is going to depend on infrastructure services. Maybe you're asking the cloud to allocate a virtual machine. Maybe you're using the logging services of the cloud. Maybe you're using some other hosted type of thing, an AI server or model server or some such. Uh, so you want to have those elements available in your test as soon as it's practical. So in the development environment, you might have a load balancer and logging. You might have a model server. In other environments, you may need other services such as registration, or if you're using an SOA, or discovery in general. So discovery is pervasive in distributed computing. Where does the input come from? Well, there are three sources. You can come from a test harness. So I showed you a picture. The picture had a tool up at the top that generated input and checked output. And so a test harness is a structure that enables you to generate input from a tool automatically. It may come from live users. Okay, so it used to be that there was something called beta test. Now the modern analog are canary tests or user acceptance tests, and you might be doing that. So the input might come from real users who are using the new version that you're testing, or it might come from real users that are have used the system in the past, and so you have recorded their input, and now you just replay it. So it's possible, these are messages. Everything is a mess in a distributed system. Everything is a message over the net. You can record those messages. If you record all the input, then you can use that as a test driver for your new version, assuming that your new version should replicate the actions of the old version. What about the database? I said this before, I'll say it again. Database has to be restored after each test. The test should be repeatable and give the same results. And any given test may be A, dependent on the data in the database, and B, may modify that data in the database. And so restoring the database after each test ensures that each execution of the test begins from the same state. If the database is large, and we'll talk about that in a minute, then this may take more time. So this will affect cycle time. Uh, configuration parameter is a value that's bound at runtime. And each environment will have a set of configuration parameters. And they will vary. We talked about configuration parameters, uh, uh, but they will vary from environment to environment. Okay, but that's part of the input into the environment. And external services. They may change from a service that broadcasts the weather, in which case you just would capture that, to one that does authorization, which means you have to actually interact with it. You don't want to interact with the production version of the authorization. You don't want to write to the production version of the authorization service. If you just ask it for services, that's okay, but you don't want to do anything that would change its state. And so the treatment of these external services depends on which environment and whether it's read-only or whether you're going to write to it. If your service is not in the production and the external service is something you're going to write to, then you have to either stub it or mock it. And then each environment has a life cycle. So environment has, and that life cycle should be finite, except for production possibly. So it's created, it's used, and it's cleaned up. And you can script or automate the creation and the cleanup steps of the different environment. So what happens during create? That's triggered by some event. The create step of the development environment might be triggered by checking something out of a version control system or creating a new branch of a version control system. The create step for the integration might be the checking of something into the version control system, and so on. So which event triggers it will depend on the purpose of the environment. And what it does is it creates the environment. It creates the virtual machine. So we saw, we had a discussion of what an environment consists of. It has to be created. Uh, Load balancer is probably in a separate virtual machine, or it's allocated from some platform as a service or a service mesh. You have to create the test harness. You have to initialize the database, and you have to create the dependent configuration parameters, and those will depend on the environment you're in. And then what happens depends on the environment totally. And then you clean up. So anything you want to save should be saved. Uh, any data that you've affected, like the test database, should be clean, should be adjusted. And then you want to remove any resources created. So it's easy to, there's a phenomenon called VM sprawl. Same thing happens with containers where you uh, create a virtual machine and then you don't delete it after it's done. Okay, so this is both a financial problem because the cloud provider will charge you for this virtual machine, and a security problem. And there are tools, which we'll talk about somewhat later, that run around and look for unused virtual machines and unused containers. And again, there are variations. Uh, One variation is to test a complete service in the development stage rather than just your own module. So the way I presented it, you're testing a module and then the whole service gets tested in the integration stage. Well, you could do that in the development stage as well. Uh, there are there's possible a variation. A variant is to do quality testing in the integration step rather than in a separate staging step. Uh, the integration stage might test various types of use cases. Multiple staging environments I mentioned might be exist for different organizations and different purposes. So again, offline discussion. Would UAT, acceptance test, be done in a separate staging environment or the normal staging environments? And how would you do that anyway with real users? How would you do that with tools? Uh, where does the data in the test database come from? So again, these are things to either look up or discuss offline. Okay, so that's the end of the first part of chapter 11. There are two more lectures in chapter 11.